All right, hopefully this is working. We don't need that on the screen. Okay, cool. I think this is on. Is this on? Yes. Okay. All right, so living world ecosystem. So this is our first unit here, all right, and it's pretty straightforward, I feel like. The thing we start off with here is biotic versus abiotic. So what's what there?
Living.
Biotic is living, abiotic is?
Non-living.
Non-living. What's the biosphere?
The part of this sphere that we live on, or the live part, or
the part where living things live, right?
Yeah.
Because if you consider the Earth, the crust is like it's like the skin on an apple compared to the actual Earth.
Yeah.
The crust we live on is pretty thin, but that's where we are. It's called the biosphere. Now, life is controlled by the availability of
abiotic
materials.
Yeah.
So some common ones, things that like living things need. What are some of those?
Water,
oxygen,
shelter. Well,
shelter.
It is not. Yeah, but
carbon dioxide,
Yeah.
sunlight, right?
Yeah.
Nutrients like phosphorus. We haven't gotten into that. We'll go into that tomorrow. Phosphorus, nitrogen, carbon, all those things. But yeah, if you don't have them, you can't have life.
Yeah.
Now, in deer, the population of deer would increase with lots of resources, right?
Yes.
But then it would reach this line right here. What is this line called?
Carrying capacity.
The carrying capacity. When it went beyond that, what would happen?
What?
When it went beyond that line, what would happen?
It would start to drop.
Yeah, they die off, right?
Exactly.
But then the fewer of them there were, the more food there was to eat, so their numbers would go back.
Exactly. Go back up. And
So it's a little cycle here, right?
Mhm.
Over and over and over again. So limiting factors. So if the carrying capacity is the maximum amount of people or organisms that fit there, the limiting factor would be what?
the abiotic.
The abiotic factors. Whatever it is that there's not enough of that they need,
Oh,
right?
well-
Shelter, food, water, something limiting the population.
Yeah.
Scientific notation and decimal notation. How are we with those?
Good.
I think we're alright.
Good?
Yeah.
Okay. All right. Pretty straightforward. Just plug it in your calculator, right?
Yeah.
So if you got 8.9 times 10 to the fifth power, just plug it in your calculator and you get 8, 9, 1, 2, 3, 4. Yeah.
Yeah.
So 890,000. Those are the same thing. It's just a matter of moving that decimal depending upon what that number is.
Yes.
Now, no dimensional analysis, aka unit conversions. So unfortunately, this isn't going to let me do too much erasing on this. Is that going to work? No, it's not. Well, anyways, with unit conversions, let's say you start with 36 inches, right? How many yards is that? How do I find that out?
So you're
So
gonna.
you-
Go ahead.
Nah, you got it.
Go ahead,
you
Scott.
got it.
Alright, so you're gonna first take convert it to feet. So you're gonna have inches on the top, I think. No, inches on the bottom.
Inches on the bottom. Very
And
good.
then you cancel it out. And then on the top, we're gonna have 1 foot. And then there's 12 inches in a foot.
The big one, yeah. The big one always gets the 1, and the smaller one gets the larger unit there, right? Hey, come on in. There she is. Perfect timing. All right. So once we have this, then the units do what?
Cancel.
Cancel out. So now I've converted it to feet. So now what?
You're gonna put feet on the bottom for another one.
Feet on the bottom, and then
Yards on the top, 1 yard and 3 feet.
yard will gain the 1, and feet will be
3.
3. Now you could also use a simpler conversion factor rather than going all the way through that. You could even do that's so weird and unnecessary. You could also do this. You know that in a yard that there is 36 inches, so you could probably just do that conversion and get it and just skip it. But either way,
Yeah.
as long as you know the conversion factors, you just need to cancel out those units and get it to what you need it to be. Okay, so it would just be 1 yard. 36 inches is 1 yard. Is that easy enough? Okay. Now, know the outcomes of the following for competition. This is I was a little disappointed with, honestly, in our what are they called? Reflections. So if 2 things are competing, you only have 2 things that can happen. Number 1, both of them die, which is not good. They don't want that. So what's the smarter thing to do? Separate and go after different resources. Now, you can do different resources at different times or in different areas, right?
Yes.
So diurnal and nocturnal. What do those 2 things mean?
Day and nocturnal night.
Daytime and nighttime, exactly. Now, when plants compete, they compete over 2 things. What are those things? Sunlight, and people forget this, soil nutrients.
Yes.
There's a giant war going on down there that you don't even really see, right? Because if you're a tree and someone else is soaking up all your nutrients, you're going to die. So you got to find ways to gain more nutrients more quickly. Otherwise, you're in trouble.
Yeah.
Let me see here. Know what a niche is. Is everybody good with what a niche exactly is?
I have an idea.
Kind of.
what it
I
is,
think
but
everybody, even I'm a little fuzzy on what it means. I hear so many different things. When I hear niche, it's I've heard it defined as a role of the species in the ecosystem. Now, your role is typically just what you eat or what eats you. It's really about where you fit in line in terms of what's being eaten.
Teachers, please excuse the interruption. Dr. Culpepper, would you please report to the
Symbiosis.
office? Dr. Culpepper,
What do we say
would you
bio
please
means?
report to the office? Thank you.
Life, all right, or in this case, living, and
Living,
sim
yeah.
means
Together.
together.
Okay.
So symbiosis, living together. There's different ways. Mutualism. How would you represent that with pluses and minuses?
Oh,
Plus,
plus.
Plus plus. Parasitism.
Plus minus.
Yeah.
Plus minus. Commensalism.
Plus
And-
negative or neutral.
Yeah,
Or
neutral.
Plus and zero. I focus on the O there in commensalism. Okay, 0 for O. Okay. Consider brainstorming or researching examples. Can you give me an example of mutualism?
When I was
bird
thinking
eating
V in the
stuff
flower.
after elephant.
Bee in the flower, good. Inside of you have more bacterial cells than human cells, right? And because of that, they're all in your gut. So they get a nice, sweet place to live, right? That's where they live, inside your guts. They get plenty of food. What do they do for you?
Give you breakdown.
Digest.
They help digest certain things you can't digest, right? Certain like cellulose type things. But it basically helps because if you don't eat cellulose, right, you actually can't digest it. But bacteria can help you break it down a little bit, and it coats the lining of your intestines. So if you don't eat your greens, you don't get a coat on the lining of your intestines, which means poop can't go anywhere. It's like someone trying to go down a slip and slide that's dry. So you want to make sure you eat your greens and get some vegetables in there to make it move through smoothly. Parasitism.
Oh.
One is harm, one is
I forgot what it
benefit.
was called, but the person.
So
Probably you and your
parasitic
parents.
wasps.
You and your parents.
I'm
You take
sorry,
from
I
them.
am not a
I was gonna
parasite.
say
Right? And you
the
gain a lot.
wasp.
No,
The
I'm
wasp,
serious.
the wasp, right? The wasp. Okay, more mutualism there in that relationship. Is that what you're saying?
Thank you.
Okay, so parasitism.
Maybe commits.
Maybe commensalism,
Yeah,
a little bit of
yeah,
commensalism.
maybe,
Okay,
maybe.
you just
Yeah.
Overall, don't really affect it too much. Okay. Now, anyway, so parasitism, it could be the parasitic wasp, right?
Yeah.
The larvae laid inside the caterpillar. Caterpillar eats, and then dies defending them. So gets nothing from that. And then commensalism.
The fish is on like the shark.
The fish and the
Yeah.
shark. Shark doesn't get anything out of
Yeah.
that.
The
They're just
fish following the hippo.
yeah. Now, some people say commensalism doesn't actually exist. On some level, you're either helping or hurting. Okay? And I mean, it's kind of true. Even if you think of barnacles on the side of whales, sometimes they have little
Yeah.
barnacles on the side of them, right? On the side of a whale. And so if they have that issue, there's my best whale.
What?
There's a barnacle. It's pretty small. It's not going to affect it too much, but it is going to slow it down a little bit, right?
Yeah.
If I have a fly landing on my shoulder and it's catching a ride, it's getting a ride, which is positive. I'm not affected. Well, I am a little affected. I need a little bit more energy to expend to move that little guy. Not much, but there's a little bit there. So some people don't even think commensalism is a real thing. But
I feel
So
like
drumstick.
at a certain like
It's like a drumstick.
It is a drumstick. Yeah.
close enough. All right, graphing and math. Be sure you can explain these graphs and do the math. Let me see. I'm not sure what graphs I'm talking about here. So, anyways, percents. Be sure you can count. Oh, the ones below. Got you. Be sure you can calculate percentages. Is everybody good with finding 70% of something or
Yeah.
25% of something? Okay. Be sure you can convert units like inches to miles. I know. Hold on. I'm on camera. I'm a little nervous. Joules to kilocalories. This is called a conversion unit. They're going to give you one probably on there somewhere. You have to then know whether you put kilocalories on the top or kilocalories on the bottom when you're using your unit conversion there. Okay? It's called dimensional analysis is another name. But that was that one with the inches and stuff that we talked about earlier. So how many joules in 2,239 kilocalories? How would I set up my conversion factor here?
Joules is smaller.
If I want to convert that to joules,
Joules is smaller.
doesn't matter. Doesn't matter if it's smaller or bigger. What matters is this. If I want it to be in joules, I want joules on the top of my fraction. Right now, joules doesn't exist. I want to get rid of kilocalories. How do I get rid of it?
Oh, yeah. So you
Put kilocalories
yeah.
where?
At the
The
top?
top and the bottom.
No. You put it at the bottom.
Put kilocalories on the bottom. That way they do what?
They cancel.
They cancel. And I want to convert kilocalories into what?
Joules.
Joules. Joules, is it bigger or smaller?
Small.
Smaller, because there's a whole lot more of them in there, right?
Yeah.
So 4184, the bigger one gets.
I
the
didn't even pay attention to that. I just.
Okay.
Yeah.
Yeah, I got you. I'm sorry. I probably should link those two up more. But
No,
that's
no,
all you
it's
have to do
fine.
here.
I should have read. I should have.
Cancel it, and then you do what here?
Multiply.
Multiply. Okay, that's how unit conversions work. Okay, canceling out those units. Now, these are the graphs I was talking about. So these are graphs of mutualism, commensalism, and parasitism. In this, we got two positive slopes, which means they both
Benefit.
Okay.
Pick you up.
Over here, one stays at a zero slope, which means
It's not.
it's not affected, and the other one goes up, so that's commensalism. Here we have one going up, and the other one ever so slightly going
Going down.
down. That'll be our negative there for parasitism. These graphs are something I can imagine you probably seeing here on the actual tests or quizzes themselves. Resource partitioning and law of competitive exclusion. You got to know both of these. So resource partitioning is when they're overlapping too much and they decide to do what?
Split up.
Split up. The law of competitive exclusion says no two species can occupy the same niche and compete for the same resources for very long before they both die. So this is it here, right? I'm good all by myself. I'm good all by myself. I'm
But
dead.
together, not
and I'm good.
so.
Okay, so competitive exclusion. One of them will be excluded from the competition.
Yeah.
All right, which means die. The only way you solve that is by doing what?
Resource
Resource partitioning, exactly.
Research.
That's essentially what we're talking about here. But here's the big one I want to talk about because this is something that I didn't put in here and I should have. It's a graph that I would show my 7th graders. I was teaching 7th grade life science. Predator-prey interaction model. So you have the number of organisms over here, right?
Yeah.
Predator, wolves is in orange and rabbits in blue. Now you can tell which one's predator or prey simply based off the numbers. Which one is always going to be more?
The
Prey.
The prey. Because what happens when you eat something?
It makes no.
We just talked about this yesterday.
You get energy from
You
it?
only get
10%.
10% of the energy, right? Therefore, a group of rabbits can only support 10% of their same number in wolves. Does that make sense?
Yes.
It doesn't really show or bear out on this because wolves are eating more than just rabbits. But essentially, yeah, your predator population is going to be 10% fewer because of that. Okay? But if we look, we notice it right here. We have the prey going up in number, right? And it reaches a max up here. But once it reaches this max up here, what then happens?
It goes right back down.
It goes down. But look at the predator population.
It does the same thing.
It doesn't really. Because this one's going down here. This one's still going up.
Well, okay, yeah, I see what you're
Why is this happening? Why is the prey population going down and the predator population is still going up?
Well, because they're still
Because
eating
there's like
more.
There's a what?
I don't know what you would call it.
Well, if you're looking here, do these graphs look similar at all?
Yeah.
Yeah.
The
but
shape of them
they're-
looks similar, right?
It's like
Yeah.
lag.
There's a lag. Why is there a lag?
Because as it's still going down, there's still like resources to eat. They haven't reached their.
They haven't reached that yet, but also think about it like this. I mean, how do I get more predators?
Oh, they have babies and it takes a while for them to grow.
It takes a while for them to grow, exactly. So there's a delayed reaction here, right? So yeah, sure, you get more and more wolves are going bigger and bigger and bigger as, of course they're having babies, but eventually those babies are going to starve and that's when the population starts to go down. But at first, it's just going to kind of keep on going up there, all right? And so you get a delayed reaction because of reproduction time. That's about all there is to it, okay? But again, once the predators get up too high, definitely the prey population has to go down. It's just there's a lag there in that. Is everybody good with this? Okay. Let's see. Terrestrial biomes. Know where biomes are and their latitudes. So latitude-wise, what's this?
Equator,
Which is
tropical, 0,
0. Okay. Next, what's this line?
30.
30,
30. What's this line?
60,
What's up here?
90.
Okay, good. All right. So looking at all these biomes here, what's the purple one?
Tundra.
Tundra. All right. Light green.
Taiga,
Taiga. Dark green.
Temperate.
Temperate,
Temperate deciduous forest. Good. And we have some over here too. There's a weird little
Chaparral.
red spot right over here. The chaparral. Very good. Right. And then if you look right here, there's actually in Washington something really weird at this elevation or this
Temperate
altitude.
rainforest.
What's that?
Temperate rainforest.
Temperate rainforest. Because of these what down here?
These
The no.
ocean.
Yeah, the ocean currents keeping California and Washington warm. It's why it rains all the time there. Same reason it rains all the time over here. Because if you look, and I hate that this is so hard to erase, but if you look specifically at this, it should be, Ireland should be in the tundra region. I mean, even look right here, tundra, temperate deciduous forest on the same island there, which is bizarre. But it's because warm water from where?
Gulf of Mexico.
Comes up through the Gulf Stream, and it creates lots of heat. You get heat and cold, and when heat and cold meet, you get lots of
Rain.
rain. So that's why they get so green over there, right? Is because of that interaction. All right, so keeping this going, we have the dark green already, we have the chaparral. What's this orangey color here? See it there, see it
That's
there.
the grassland. No. I'm so sorry. Oh my god.
It is a grassland,
It's a temperate grass?
but it's a temperate grassland. Exactly. Because these yellow ones down here are what?
Tropical grassland.
Tropical grassland is better known as a
Savannas.
savanna. Exactly. All right, that's the name for a tropical grassland. Now the pink ones,
Yeah.
That's a desert. Okay. Why is this purple here?
Because of mountains.
Oh, because of mountains.
Yeah.
Because of the
yeah,
mountains,
yeah,
exactly.
yeah, mountains.
Because of those mountains. Is there a way I can? Maybe not.
I
Right
don't
there.
think so.
View. Is there a clear button or clear
So
writing?
like an
Can't
undo
you like just like reset? No,
I guess I can close it down and open it back up. That's probably not too bad an idea. Comment, zoom, rotate, view, read aloud, tools, export PDF. None of that.
No.
Okay. All right. Well, let me do this. No, I don't. I'll open it back up, and then we'll try there. Okay. So close you down. Bring it down. All right. So right here again. That's better. Looking at.
Oh, now I won't even zoom in.
Okay. There you go. All right. So now looking. Oh. There you are. Okay. What's the red stuff?
Tropical rainforest.
Tropical rainforest. Very good. All right. So the big thing that you need to know about this map on the Earth is where the rainfall occurs. Because where rainfall occurs, you get lots of water. Where you get enough water, you get lots of trees. Because that's one of the big standards here, right? So where do we get the most water?
Tropical rainforest.
At the equator, tropical rainforest area, right? All right. So that's where the warm heat from the sun evaporates water. It goes into the sky, right? Once it goes into the sky, where does it go?
It spreads out.
It
Okay.
spreads out. It either
Well,
goes down this way or it goes this way, right?
yeah,
But since it
okay.
goes so high, it starts to cool. And as it cools,
then-
you get more and more what?
Right.
Rainfall. But then look pretty quickly here. It goes up and immediately comes back down. And at this location, it's what? It's dry, right? And that's where you start to get your deserts forming in here. And again, ocean currents play a big role in this. But you get those little Hadley cells, currents, right? So then it comes back up over here, and you get lots of rainfall. And then it goes back down, and that's where you have the tundra, etc. Okay? And it's these little Hadley cells forming all through here, okay? Which is just convection currents. But anyways, wherever you get lots of water, here and here, we see that there are lots of these green things and these red things, rainforest and forest of some kind, right?
Yeah.
Because there's plenty of water. Does that make sense? So we're talking about timber, where you're going to find it. It's got to be plenty of water and nutrients in the soil. Now, 1, 2, that should be enough. Okay, direct versus indirect sunlight. What do the poles receive?
Indirect.
No, indirect.
Indirect sunlight, right? And it's got to be that way because it's so cold over there, right? And so direct versus indirect determines the climate. In fact, you're going to start noticing here pretty soon we're going to get less and less daylight because we're going around the sun, and we're going to start, instead of facing towards it, we're going to be tilted away from it. Less direct, so you get less time with the sun. Climate is the temperature and precipitation over a long period of time. A big thing, climate change, people who don't believe in climate change talk about is, it was really cold yesterday, so much global warming, huh? Well, they forget, climate is over a long period of time, so it's an average of the entire year. And I think in the past 13 years, 12 of the 13 hottest years ever have been in the past 13 years. Just pointing that out there. But we'll talk more about that soon enough. What's this albedo thing?
Is
So
when
Reflection of the sunlight off the ice and the
Off of the ice in the Arctic, right? So it's reflecting and going into space, but the more the ice melts,
less ice caps.
the less of the ice caps are present, right? And so less ice cap present, more of that sunlight goes into the water, and the water heats up, therefore melting more ice, and you get what's called a feedback loop. In this case, it's negative, right? Ice goes down as temperature goes up, and it just feeds on itself.
Okay.
All right. I think that's what it talks about here. Hadley cells are the convection currents that determine the Earth's precipitation in different biomes, and you can see that here. Desert regions are where that air is coming down. It's cool and it's dry. You get some rainfall up here, and so you get, again, more trees. You can actually see the trees on here. Lots of rainfall, lots of trees. Less rainfall, less trees. Pretty straightforward, right? All right. Let me see. Blah, 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 blah. Ocean currents affect climates around the world. Ireland shares the latitude, right, with the Yukon, which is a pretty cold area in Canada. Not a lot lives up there. But you get lots of plant life and everything else in the British Isles because of the Gulf Stream. Can everybody see that? All right. So in terms of determining biomes, it's all about the climate. So whatever affects the climate, it can be tectonic plate shifting, putting things in different locations on the Earth. It can be ocean currents. It can be direct or indirect sunlight. All these things determine the climate of a region, and a biome is based off its climate. That's kind of the main thing to understand here, okay? So again, why is it so nice and warm over here?
Because of ocean.
Because of the nice Pacific Ocean currents. All right. Okay, I feel like I'm repeating myself, so I'm sorry for that. Bless you.
Thank you.
Now, the one thing I will say is this is what it says in your actual standards. Biome locations depend on climate, and climate depends on direct or indirect sunlight and altitude. What's this?
How high is high?
How high it goes, right? I did have one person in their reflection here mention altitude as towards the North Pole, right?
Oh.
Which makes sense because you're looking at it, it's high up on the Earth, right? But they're forgetting it's not about altitude, that's off of the Earth, okay? What she was talking about was
Latitude.
latitude. Does that make sense? Okay, so high latitudes. Now, what's interesting is the high latitudes can be at the North Pole or at the South Pole. Both of them are high latitudes.
Yeah.
It's just the ones above the line are positive, the ones below the line are
Negatives.
negatives, okay? Or north and south, however they choose to represent it.
Yeah.
Okay, know your climatograms.
Oh yeah, that.
Use your worksheet and study those, okay? That's gonna be an important part of any biomes related quiz or test is your climatograms.
Yeah.
So if you notice that you've got a pretty steady temperature like this, you're probably where?
Tropical,
In the tropical, right? If you got a pretty nice little jump,
temperate.
probably temperate, right? And if you're getting even more of a jump, right, at certain times of year, you're probably talking about Arctic there, right? But it's got to go below 0 in that case, right? That'll kind of help you figure that out.
Would it be the same for desert, just high temperatures?
Yeah, and you can have deserts in different areas too, which makes it even like harder because it really depends on where the desert is. But for the most part, you're going to see I don't know how best to describe. You're probably going to see pretty consistent temperatures in there. Because the weird thing about the desert is, even though it has pretty consistently high temperatures, it's the fact that at night it gets really cold.
Yeah.
Do we talk about why it's so cold at night?
Yeah.
Why?
I think it's like.
Deserts are really cold at night because
it's really dry.
exactly.
So the heat can't, like here, and it's a lot of humidity.
Because
so
water is like a
Water is in.
there's no water.
Yeah, it's an insulator. It's an
Insulator,
insulator, right? So it holds heat in. So since there's no water in the air, it can't hold any heat in. And so the water is a global warming gas. All right. So because there's very little water there, you don't have a whole lot of heat being held to the earth. So, anyways, moving on down here. All right. So Billy familiar with at least one producer from each biome. So, what biome? Cactus,
desert.
desert, shrub,
Ground.
shrubland. Let me see.
I was gonna say grass.
Like it.
Redwoods,
Is temperate decision?
temperate,
Oh.
Or temperate.
No.
Rainforest.
redwoods, rainforest,
Yeah.
redwoods.
Redwood,
In California. Those redwoods, what do you know about them? They're like the
Really
biggest trees that we
tall.
got, right? Why do they get to grow so tall?
Because lots of water. nutrients.
Lots of water and nutrients, exactly. What you get over there. Make sense? All right, pine trees.
Temperate.
Tiger.
Deciduous?
No.
No.
You'll get them in temperate deciduous, but they're primarily taiga related.
Not
Taiga, okay? Temperate deciduous forests, you're gonna find the broadleaf ones, right?
Yeah.
So oak or
Yeah.
maple or whatever, okay? Let me see, grass.
Grassland.
Grassland, where else?
Savannah.
Savannah, where else?
Shrubland.
Tundra. Shrubland, yes, and tundra as well, right? Because when it does heat up and the ice melts, you get a healthy thin grass growing, and that's where all the caribou eat, right? They come up there, they eat, and in fact, lots of organisms migrate up there at that time of year because it's got tons of nutrients in there. It's just unlocked when it melts. Okay, so I think we're good on timber and water. They're found in areas because of precipitation and, of course, those nutrients. All right. Let's see. So, do we need to take a break or are we good?
No, we're good.
We're good? All right. Aquatic biomes. What percent of the world's water is found in oceans?
98%.
Yeah, 98, 97%. It's up there, right? So rivers, lakes, and swamps, we're talking about how much?
Yeah.
Maybe definitely less than 2. In fact, it's way less than 1 for all of these.
Yeah.
Because most of the rest of the water has nothing to do with these.
Right.
Where's most of the 3% of the water that's actually fresh is mainly what?
Underground? No.
Underground.
Yeah.
All right, so groundwater. What else?
I'm trying to think of that little chart that you did.
Just think about it logically. Where's the fresh water? We got underground, and where else is it? If it's not in lakes and rivers and swamps, huh?
Ice.
Frozen.
Ice. It's frozen. Frozen. Ice caps, right? And here's the problem. Once those melt, where do those go?
In the ocean.
In the ocean. That's a little unfortunate too. So we're kind of in some issues here. But yeah, ice caps, groundwater. That's where most of our fresh water will be. Okay, in those two places. Now, of the remaining fresh water, and again, This is only maybe about like, I think maybe 1% or so is not groundwater and ice. And that's where these are. And of those, which of these has the most water? Lakes. In fact, we have most of the Earth's fresh water in the Great Lakes. That's where most of the Earth's actual fresh water is. It's in those Great Lakes up there, formed by glaciers years and years ago that melted, right?
Yeah.
Okay, but regardless, most of the fresh water is in lakes and it's in the Great Lakes, so we're not really close to that. So the only fresh water we really get is rivers. Which river? Chattahoochee. Believe it or not, you hopefully learned about this in 8th grade. I don't know if you learned about it in social studies since then, but there's been lots of fights over that river. Between who?
I didn't know about that.
Lots of fights over that river between Georgia, Alabama, and Tennessee because it goes all the way up there and cuts as a border between all of us at different stages, right? And so whoever controls the water, right, gets the fresh water. Because think about it, not only do we get our fresh water from there, we also dump our dirty water in there. So you really don't want the people upstream of you dumping a whole lot of bad stuff in there, right? Because then it comes down to you here in Columbus. Like, you have no idea what's been through that water, right? We clean it, and it's crystal clean when it comes out that tap, but you wouldn't want to know what's in there, okay? Anyways, don't gurgle the water when you fall out of the little boat when you're in there. Don't gurgle it. I mean, you'll be fine, but don't drink it.
Like swimming in the Chattahoochee?
Yeah.
Oh, okay. I was like,
Yeah.
what?
All right, so I'm sorry, my brain's going like a million different places. But groundwater and ice is where most of our fresh water is. All right, what does this tell us about the importance of protecting our fresh water supplies?
It's very important.
It's very little of it available, right? I mean, there's something we can do here. They do a lot in the Middle East. Desalination?
Yeah.
Sal meaning what? Salt. So they have, the Arabian Sea and stuff over there, right? The Mediterranean Sea. So they can get that water and they can just basically do what to it?
Take out the salt.
You can't take the salt out of it.
Then what that mean?
You can take the water out of the salt, if that makes any sense.
Yeah.
Take the water out of the salt water. So what you're doing here is you're doing what to remove the water from the salt water? Evaporate it, which takes a lot of heat, and energy, which means you have to have a lot of what to do that? Money. And guess what people who live in the Middle East happen to have a lot of?
Money.
Because they have lots of oil. Bingo. So they can afford it. In fact, the Dubai, the city or country or whatever, Dubai, that's hosting the World Cup right now, they actually paid for it. They're going to be hosting the World Cup next. They paid to do it. It's highly illegal, but they'd already got it started before they started charging people. So holding it there. But the city itself shouldn't exist because there's not enough water to support that population. So they literally have to bus water in to keep people there. And so if that transportation line had any issues, they would not survive very long in that city. But it's beautiful if you've ever seen it. That big old tower, you know what I'm talking about?
Yeah.
The largest one in the world. Okay, sorry, brain, ADD, really bad. Okay, so what does this tell us about the importance of protecting the areas? All right. Principal abiotic factors in the aquatic ecosystem. We got salinity, which is what? Salt, depth.
How deep it is.
And what do we know about lower depths?
It's
More
cold.
pressure.
More
And
pressure?
No light.
Cold, no light. Exactly, right? Turbidity.
How see-through is it?
Yeah.
How much you can see through it. So here's the thing. The more turbid it is, odds are the more nutrients. Is that a good thing, having more nutrients? Yes
Depends.
and no.
Yeah.
Depends on the extent. I think we may have talked about this, but if you throw a whole bunch of nutrients into water, what's going to grow in those locations?
Algae.
Lots of algae, right?
Yeah.
And as the algae die and they get decomposed, the bacteria is performing lots of respiration. And they do so much respiration, the bacteria in that water then sucks up all the oxygen.
Yeah.
So what happens to the organisms that live in that water?
Yeah.
They die. Yeah. Algal blooms are terrible things because they kill all the living, like the aquatic species that live in
Wait,
those.
what's the plural of algae?
What's the plural? Well, actually, algae is plural.
Plural, yeah, I know. You said
Alga.
Alga, yeah.
Alga would be the singular.
Singular,
Right?
yeah.
Algal blooms, I think is what I said. So algal blooms, like the
Oh.
adjective.
Yeah, okay.
But alga will be singular and algae.
Algae is
Feminine, right? So you have your
Get
alumna.
it together.
Alumna would be what you will be, and you will be in like 9 months.
You don't know me.
But together, you'll be alumni.
Alumni, got it.
You will be in 2 years and 9 months. Yeah? An alumnus,
What if
masculine
I wanna,
ending.
What if I want to be a
And then both of us will be alumni. If you want to be that, you can be whatever you want to be. Just choose your gender ending.
Then I'm an alumnus.
Or
in
you
the
could be even
future.
cooler and do gender neutral, which is alumnum.
Aluminum.
All right. I don't know why it's like aluminum, but yeah. And then plural for alumnum is alumni anyway. So.
Yeah. Gotcha.
Okay. Sorry. ADD.
You're fine. You're
Why-
just way too smart.
Time. I got half an hour. I'm barely halfway
that's
through.
right.
Time. That's why.
Okay.
You guys have Mr. Ellis. Focus.
Yeah.
Throw things
Focus.
out.
Okay.
Focus.
Why are algae and phytoplankton so important?
Oh, because they are the base of the
The base of our
ecosystems.
energy pyramid, right?
Yes.
If they're not bringing energy into the system, nothing else can exist.
Mm-hmm.
Okay? Now, phytoplankton would be the
Floaty
Plants.
floaty plant-like things. Zooplankton would be the
Animal.
floaty animal things. All right, label is fresh, salt, or whatever. Mountains.
Fresh.
Fresh.
Yeah, I guess maybe we're maybe the ice on the mountains. Is what
Yeah,
we're
that's
saying? Okay.
yeah.
That's dumb. Okay, river,
Fresh.
fresh. Lake,
Fresh.
estuary,
But,
What's it called?
Rosker, bro.
Brackish.
Rosker. Both. Okay, at some level. So estuary, it's where they
Don't
meet,
know where
right?
that came
River,
from.
ocean
Yeah.
meets, you get the mixing. Marshland.
Kind of brackish.
Yeah.
doesn't the estuary make the marshmallows?
Yes, exactly.
Yeah.
It's the estuary makes the marshland. So you're gonna get a lot of that brackish water in there.
Brackish.
Probably more fresh than salt, but I'd still say some salt in there. Coral reefs,
Salt.
Salt.
salt, and they're found typically on the
Continental shelf.
continental shelf, right? Okay, good. Is fresh water actually fresh?
No.
Where does the
fresh,
salt
right?
then come from?
From some halite.
Halite.
I always add an O
So
in there.
hal there.
Exactly.
He's talking about the halogens and the halogen family, which is group number 17 of the periodic table, the ones just before the noble gases.
Hey.
All right, where does the salt dioxide come from? Where does the salt dioxide come from? Because of this halite, and as the water travels down, it weathers it, breaks it down, and the salt gets into the water. But remember, the ocean ends up being like just a giant repository. All right, we're going to talk about reservoirs soon enough. It's a salt reservoir. It just all the actual salt just dumps in there, and it builds up over time, and then it layers in the bottom of the floor of the ocean, and then forms into more halite as the pressure crushes it down over years and years. Okay, what is lentic?
Forgot.
Oh no, that's
Standing
Oh,
and
standing and
I
moving.
don't.
Lotic, the word I look for there is flow. So if I have lentic, I'm gonna be like, all right, what's the other word again? Oh, lotic. Okay, that's the flowing one. That's the standing one. Okay. I guess lentils. Lentils don't move.
Nope.
Okay, so flowing, not flowing. What is a water column?
A column.
Yeah.
A column of water.
Yeah, it's a vertical column of water, right? And so we know that higher up, what can reach down higher up in this
Sunlight.
sunlight, and lower down it's pretty much pitch black, cold, pressure, etc. Okay. Why are some lakes and rivers so pristine and blue?
Because they have no nutrients.
What's that called?
Oligarchy.
Yeah.
Olive Garden.
Oligarchies, right? Not Olive Garden, oligarchy. Oligotrophic, right?
Oligotrophic.
So low food nutrients, low nutrient levels, okay? And the other ones that are so dark and brown,
That one starts with a
eutrophic. So EU meaning true.
True.
Okay,
Yes.
it's got, or just lots in this case, right?
EU.
Lots of nutrients. Model the lentic zones and be sure you know what the abiotic factors are like in those locations. So the lentic zones in our lake, if you remember,
Yeah.
first section,
No.
The
Lentic zones in our lake. Wait.
well, what ends up falling in these little areas is lots of little leaves,
Yeah.
right? Leaf litter, right?
Yeah.
So I call this, or this is called the littoral zone,
Oh, right.
littoral zone.
Littoral. Yeah.
Okay?
Leaf litter.
This one out here in the open area,
is the literal? No.
No.
limnetic. All right, limnetic, right? And then you have below that, you got the profundal zone.
Yeah.
Profundal?
That's, yeah.
Yes.
Profound.
Because
and
it's
then-
profound, it's deep,
Yep.
right?
And then
And
you
then
have the benthic.
The benthic layer. Now, the benthic includes the sediments at the bottom,
Yes.
but that's where your worms and decomposers live, right?
Mhm.
As things die and decay up here, right, or over here, all that moves down and then they chomp on all the remains. Now, model the loadic zones. So, in terms of loadic zones, we're talking about rivers. All rivers start where?
At mountains.
In mountains. So, we got mountains, and that's called the what zone?
The start of no, it's
The soul.
Source.
The source zone. Okay, so we got a source zone, and you have these melts, right? And it comes down, and it
Runoff.
flows
Yeah.
down, and then you have this kind of Then you have this middle.
It's another page.
Then you have this
so it's
middle
not-
area here
Oh.
called the.
The travel,
There's
the
a source zone.
the
Yes.
the
Transition.
transition. I was gonna say that.
Now in this transition zone, this is where it's picking up lots of what?
nutrients.
Nutrients. No nutrients whatsoever, pretty much, because it hasn't had time to erode anything, right?
Exactly.
Nutrients end up falling. Dead, like just people, things, animals
Ew.
die. They
Ew.
drop waste in there. You know what I mean? You name it. It picks up nutrients from that. Leaves, whatever. It picks up oxygen as it's churning.
Yep.
Either way, the transition is where it's picking up those nutrients. And then eventually it's going to run into this big thing called the
Ocean.
ocean. And when it does, it stops. And when it stops, it starts to spread out
Yeah.
and forms these things called
marshland.
marshland. But this would be the floodplain zone.
Oh, floodplains. Okay.
Floodplain zone, right? Now,
Hey.
are there a lot of nutrients or a few nutrients here?
Oh, that
A lot, because it's picked them up all through the transition process.
floodplains. Got it.
All right. Now, what different types of stratification are there? What is stratification?
Is it like oxygen or something? No. No. Yeah. Never mind. No. That's okay.
Stratification.
That's alright.
Layers.
Layers.
Yeah.
Stratified. Okay. Stratosphere is one of the layers in the atmosphere. Maybe that'll help you remember stratosphere. So stratified is just a layer up here, right? Now, what types of stratification are there? Well, you can have many. Name one.
Thermocline.
What?
Thermocline.
Thermocline, which is the heat one.
The chemocline.
Chemocline, which would be for oxygen.
Tempocline. No.
That would be a
It's
time.
it's the salt one. I forgot.
Halocline.
Halocline. Yeah.
All right, we're sticking with the halogens there, right? Okay, cool. So we have those, and they exist. The problem is, if they do exist, the water's not doing what? Mixing. What's up here that they need?
Oxygen.
They don't have it down here. How's it going to get there? The only way it can is if it cycles. The name for that cycle is overturn. Okay. Now this can only happen when the temperature in these areas
Are
is
the same.
the same, right? So you have the same temperature, 10 and 10, and then you'll have your normal cycle because as the wind blows over, it makes the water move and pulls water from below, and it just cycles enough to keep the things alive down there. But if there's a temperature imbalance there, right, then the hot water stays high, the cold water stays low, and the things at the bottom die. Okay? So if there's no overturn, that's a problem for the living things at the bottom of the lake. You good with this? All right. How does the thermocline affect turnover? Well, I just went through that. Okay. What does riparian mean? I really forgot to put over this, but this was in my slides though. Riparian means a river.
Oh.
Do you remember when you saw that little thing of the bear? When we were watching the bear, whatever on the thing? I was supposed to keep on saying this word over and over again, but I forgot. And that's riparian. It just means river or river areas. Okay, they can use lotic, or excuse me, lotic, or they can use riparian to mean river. Okay, it really means close to the shore, where the organisms live. How does organic matter get into the streams and rivers? Well, leaf litter falling, things dying, things pooping and peeing in those rivers. Organic matter gets in there. How does dissolved oxygen get in?
Yeah. Okay.
I'm sorry. It's just that sound. It's really creepy and it's distracting me.
Which sound?
Right.
I'm talking too much for that.
No, it sounds like
Just keep going. I'm
Okay,
sorry.
I'm sorry. All right.
You hear it?
Yes, you're not crazy.
Okay.
Cause I thought I'm
Oh, it's probably
looking
the
at
dance
like,
studio,
is
maybe?
anybody like hearing this?
All right. So as the water moves through our little river here, right? Sometimes there are rocks in the way, and they hit them, and spray goes everywhere, right? And as it sprays, all right, and things are moving everywhere. Well, what's going to start getting into the water then? When it starts being exposed to the air, you get more oxygen. You got to expose it. That's why you put bubbles into tanks where fish live to get actual oxygen in there. You have to put bubbles in, okay? So that they can diffuse through. So why are floodplain zones so murky and brown?
Well, because it's all
Which would be called what?
Eutrophic.
Eutrophic.
true.
All right. Why are what are mangrove forests and where are they found?
Oh,
Oh,
man,
they're
they're
right
They're
before
like
you
little
get
things
to
that
the
like
protect the
dam.
land from
Trees protect the land from
It's
the
like
the waves.
tide.
Yes, and they prevent erosion too, right? They prevent
Yeah.
erosion, and if they go away, then you're going to erode the beaches and organisms where they live, and of course people and where they live. So people need to take good care of them. Remember, they're being destroyed by those what kind of farmers?
Shrimp farm.
Oh,
Shrimp farmers, right? They were producing too much waste, too much nutrients, algal blooms, killing things, and poisoning the water there for them. Okay, so that was a big problem. An estuary we already covered, right?
Yes.
Where rivers and oceans meet. Are there a lot of nutrients in the open ocean?
No.
Wow.
Yes and no. So the answer is no, but it's no relatively because it's so spread out, right?
Yeah.
However, because there's so much of it, if you were to add it all up, the total sum would be really high. But on average, there's very little, right?
Mhm.
Because there's not really that many, living things in the top layer of the ocean. Okay, but if you were to condense them all in one little spot, there'd be tons. So it depends on the area you're talking about. Where are you more likely to find nutrients though in the ocean?
No, just at the top.
At the top, yes,
And
but
near the shore.
at the shore, more at the shore. Top for sure, but the shore is the better answer there because again, that's where you get the rivers dumping what? Waste, nutrients and stuff, right? From the in the floodplain zone. Okay, what is the intertidal zone?
In between tide, yeah.
In between the tides, exactly. So high tide, low tide, and what causes the water levels to change? The moon, right? Pulling it up, pulling it down. So different organisms have to respond to that, and they have to adapt to that change. What kind of conditions do creatures face at the bottom of the ocean?
Oh, it's cold.
Cold.
No light.
Pitch black,
And
lots of
Pressure.
pressure. Okay. Where do they get their food from all the way down there then?
From
They
animals
wait for
dying.
it to die.
Animals
and then
dying
it just
above.
drops.
And they just drops, right? So whales drop, but don't forget, so do all the phyto and zooplankton. It's called marine snow. And
Yeah, that's
there's a
right.
video I was dying to show you, but there's just no time. Like I'm really irritated with how little time I have to show you some of the cooler stuff. But like, it's just marine snow. It just falls down from the surface, and little creatures they just sit down here, and there's little fans. They hold the little fans up, and the marine snow lands on it, and then they just eat it, and that's all they do all day. They just sit there like this, and just catch marine snow and eat dead plankton. That's their whole life. All right, looking up at light that they'll never truly see. Okay.
That's crazy.
Now, energy and ecosystems. What does the suffix troph mean? Or prefix, I suppose. I mentioned this one already. Oligotrophic, eutrophic.
I don't.
Light.
Not
Is it
layer.
Oligotrophic was talking about having few what?
nutrients?
Few nutrients. So what does troph mean?
Nutrients.
Nutrients.
Oh.
Okay, food. When we talk about trophic layers, we're talking about food layers, energy pyramids. Okay? So troph means food or nutrients. All energy on Earth comes from the sun.
Yeah.
All right? Draw a correct food chain or web. What are you going to do here, in fact, just to mess it up?
Draw the arrows pointing down.
Draw the arrows pointing the wrong way, right? So here's my flower. Right? There's the sun. Which way does the arrow go?
To the flower. Or no, wait.
To the sun.
No, wait.
No,
Oh.
no, the sun
Because
goes
the sun
down
ain't
to the
eating
flower.
that flower.
If you were in 7th grade and you're trying to draw this, I'd throw things at you. Right? I would be that upset. Okay? So this would be something, especially in biology, I would like kill you on because it can't happen. Because you might know, make a beautiful food web that should get you full credit, but just one arrow being the wrong direction throws off everything. Okay? Because it means the wrong thing. This means that these guys are flying off into space and the sun is eating them. Like that's not. Okay? Other way around. The arrows show the flow of what?
Energy.
Nutrients.
Energy and matter. It's two
Matter,
things.
matter.
Again, this is what I harp on in my 7th grade class because I know it comes up. So, again, energy and matter. I'm only existing because I ate spaghetti last night. I ate a lot of spaghetti last night. Okay, so there's probably a lot
I
of matter in
love
me than there was yesterday.
spaghetti.
Okay, but it's my fault for making it so good.
Dang, man.
Oh yeah, okay, sorry, yeah, all right. Organisms need the continuous inflow of high quality energy or they die. Right? If anything interrupts that flow, the organism's in trouble. Right?
Correct.
So we have to think about that as humans, right? Keeping that energy flow going to them.
Yep.
Now, be sure you know what carnivores are.
They meet
Herbivores,
plants.
producers.
They are the ones
They
that
produce.
They get energy from sunlight,
Yeah.
right? Produce glucose.
Yeah.
Primary means
First.
first, secondary,
Second,
tertiary.
third.
Now, primary consumers. What's another name for a primary consumer?
Produce? Is that what?
It's a
Primary consumer.
Herbivore.
Oh,
consumer.
Oh my
Primary
God.
consumer. Who eats first?
No.
Herbivores.
Okay, I kept saying it.
You don't
Primary
eat.
consumers. All right, primary consumers.
Oh.
Secondary consumers.
Goes
Carnivore.
we
That has to be a carnivore because what are they going to eat?
gotta eat.
Yeah.
The herbivore. So they eat second, right?
Exactly.
Your things you eat first,
Exactly.
then your things you eat second.
Exactly.
Tertiary consumers would be carnivores that do what?
Eat the carnivores.
Eat other
Small,
carnivores.
yeah.
And the very rare existence of
Quantity.
quaternary
Quaternary.
consumers. Carnivores who eat other carnivores who eat other carnivores. Can you think of any organisms that do that? That's right,
I
yeah.
mean,
Or killer whales, things in the
Yeah,
ocean.
yeah,
But
yeah.
it's harder to do it on land, primarily because it's harder to get the kind of resources you need on land. It's easier to do in the ocean. All right. Matter can't be created or destroyed, it can only be changed. So all the atoms we have on Earth have always been here and will continue to be here. That is the law of conservation of mass. Right? And that matter itself is cycle. Now we're going to talk about this tomorrow, but the major atoms for living things are Chon and P. Okay? I used to have a girl I had a huge crush on. Well, there was a girl I had a huge crush on in middle school, and her name was Betsy Chon Crawford. And so we would always talk about, well,
Oh,
she was nutrient
what a
rich.
nerd.
I don't know. But anyway, I had a huge crush on her. Her name was Betsy Chon. I haven't forgotten that. But yeah, now there are other ones. Did you say some other phrase for it?
Yeah, it's chopping or
Choppin'?
yeah, chopping.
Oh, choppin'. Okay, I like that.
Choppin'.
Choppin'. I'm focused on Betsy Chon Crawford. That's choppin'.
Yeah,
Okay, I like that.
chopping.
Yeah. Same thing, same idea. All right.
One.
Now, these atoms run through cycles, right? So make sure that we can all get to them. We're going to talk about these cycles tomorrow. What's the 10% rule?
It's
The
that's
organism
how much
that eats
energy
the
you're getting
organism
from
only
it.
gets
How much
10%.
energy the organism needs. It only gets 10% every time something's eaten.
I'll just
Yeah.
go back.
All right.
I'm pulling that too,
So
because
how does
that's
it
what I
explain
want.
why there are so few apex predators as compared to the herbivores?
Because
You only
they
get
only get
10% of the energy.
10%.
So their numbers are going to go
Down.
down because there's just not enough energy
Can't
to get from
sustain
them.
too many.
Can't sustain too many. Sustainability is a big thing we're going to talk about soon. Now, producers have this much energy. How much energy will the tertiary consumers have?
Oh,
567.029.
Yes. But in terms of how you do that, right? You start with the producer, 5,600, and then you do what?
Who's decimal?
Find 10%.
Yeah.
Multiply by 0.1,
One.
which technically means
Boop.
1, right?
Yeah.
Tertiary, so it's primary,
Boop.
secondary,
tertiary.
tertiary.
Yeah.
Okay? All right. Always check your math, though. It's not worth it just to do it real fast and then miss it. What are the equations for respiration and photosynthesis?
CO2.
Wait, which one? Let's do respiration first.
Respiration.
Respiration is what?
So
C.
6.
C6H12.
C6H12O6. I'm crazy.
Yeah.
Plus
What you need glucose, you need
Water.
Water.
Oh.
oxygen.
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 We think we need water
I've
in the
forced
right
it, I've forced
Water
it,
is
yeah.
mainly for our cytoplasm at this point,
Yeah.
okay?
Okay.
And for making our muscles relax. But
Mhm.
regardless, all right. So next, what do we make?
We make
Carbon.
carbon dioxide and water.
CO2 and water. What do plants need?
Carbon
Yeah.
dioxide and water.
And
All right. And so we just take this arrow and do what?
Switch it around.
Ow.
Flip it.
What time does this end?
10 minutes.
5? 4:30?
Yeah.
Okay, well, okay.
I got a lot. I gotta go pick my kid up. I gotta get the water taken
No,
care
no,
of.
just keep going, Mr. Ellis. Don't talk about that.
Okay, sorry. All right. Do plants do respiration?
Yes.
Yeah.
Yeah, they have to.
Yeah.
But here's the thing: they can't move around and eat, so they make their own food, but then they still have to break it down. They still need ATP. All right. Blah blah blah. In terms of primary productivity total, rank the various biomes. Primary productivity total. This is a weird one, and this is the sheet that we're going to work on again tomorrow. All right. So I'm not as concerned with covering this with you ahead of time as I am with making sure we've got what we've got so far. So. In terms of total and then average, we're going to discuss that tomorrow. Okay? Now, I got 5 minutes or so here. What, from what we've covered thus far, is the most challenging?
The only thing that I have a problem with is the little
Climatograms?
Do you want to practice the climatograms real
Yeah,
quick?
because
Okay.
those.
Sit at this round table here.
Okay.
Wait, what about the video?
Tough.
You're not even live streaming it. Mr. Ellis, you're getting... What is happening? Okay, but, Mr. Ellis, please.
She really didn't like that.
There you go. There you
Is
go.
that Connor?
Yes. Okay.
Her name is Connor?
Yeah.
Yes. Oh, with an E. Okay, tell you what, right here, since you're over here. 1, 2, 3. Smash them up.
I'm gonna have a hard time with this because I'm telling you right now, I don't know this. I have a very hard time understanding it.
The best way to understand this is to think in terms of temperature. We just showed that on the board earlier, right?
Yeah.
If it's tropical, what do we know about the temperature?
It's gonna...
Consistent. Temperate, up and down, but
But not
too low.
Yeah, yeah.
And so Arctic would be below 0. Focus on temperatures first.
What is a tropical dry forest?
So, I mean, things are going to exist. As weird as it sounds, you know, we generalize so much in education just to make things simple. But crazy, weird things do happen and exist. Like, you can have examples of pretty much all of these things.
Yeah.
I bet there are, you know, some wet deserts somewhere. I don't know. But there are cold deserts, for example, that I didn't really know until I got much
Yeah.
older.
But a wet desert makes zero sense. Because if it was wet, how would it be a desert?
Well, let's think, well, where could it exist?
So
Well, it would have to exist where there was a massive amount of, maybe not rainfall, but maybe you could have monsoon type situations where there's lots of rainfall and it's like just making its way into the area, you know? I don't know. I just made it up. But the point is, these things can
It
happen.
could happen.
Are we getting these mixed up?
Yes.
Because we're too close
Please
together?
excuse the interruption.
No,
Miss
oh, I
Andrews,
meant
could
like
you
I
please
mixed
report
up.
to the front office? Miss Andy, could you please report to the front office?
Oh,
Thank you.
Why?
Because we're done.
Well, I'm recording it.
No, keep it recording. Just
So they
so
do
can
listening?
experience-
An experience? Okay.
Experience what it's like to be here.
Yeah.
The fam. Oh, I didn't give you consent.
You
for
didn't?
This.
Okay, I'm sorry. Okay.
I'm joking.